The objective of this lesson is to be able to graph sine and cosine with either amplitude or period changes. We're going to look at the basic family of functions for both sine and cosine, and then we're going to look at when you stretch it horizontally, which is a period change, or if we stretch it vertically or shrink it vertically, which is a amplitude change. So if we look at the standard graph for sine, it starts at 0, and then it goes from there out to and starts repeating again at 2 pi. So once it repeats again, that's our period. The same thing happens for cosine. If I start here at this point and I go all the way till it starts repeating again, my period for this family of function would be 2 pi. If I were to think of that in degrees, that would be 360 degrees. Now, amplitude is the measurement from the middle of the graph up to the top, or from the bottom to the middle. Amplitude is always a positive value. So amplitude here would be 1, and also here would be 1. So both of them have the same amplitude of going up to 1 for amplitude, and it goes also down to -1 from the midline. So that's the family of functions of what the basic graphs look like. Now we're going to take them and we're going to stretch them either horizontally or vertically, making an amplitude or a period change. So looking at these two graphs, we have some commonalities here. If you look at these two, the A in front, that affects the amplitude. So the amplitude is just that value in front. If you multiply it by 5, it's going to go from the middle of the graph up 5 units, from the middle of the graph down 5 units. Now the period is going to be affected by this middle number. This number here, that B affects the period, or horizontally stretches it. That's going to be, we're going to take 2 pi over that value, B, or 360 over that value, B, if you're going to do it in degrees. And how that works, notice that it works like the other families of functions we've done. Whenever we've done other families of functions like square roots or quadratics, when you look at the number on the inside, that affects it horizontally. The number on the outside affects it vertically. Same thing happens with sine and cosine. There's consistency on how those numbers affect the family of functions. So let's go ahead now and look at how we're going to graph just this standard function. Again, sine looks like this, where it goes up and down and then back to the axis here. How high up it goes will be A. How far down it goes then will be the opposite of A. And then its full period out here will be 2 pi over B, or 360 over B, whichever we're doing, radians or degrees. Now cosine, on the other hand, it starts at the top of the amplitude. So it's going to start up here at A, and it's going to go down to -A, but it's going to go down, hit the bottom point at -A, and then come back up before it repeats again. So this value out here again is 2 pi over B, or 360 over B if you're in degrees. So now what we want to do is be able to take these values and come up with graphs with using some steps. Now, I'm listing out the steps of what I call the 5 points to graph the period. What we'll do first of all is we'll look at our equations. We'll do this one in degrees, this one in radians, so we see that you can do both. But what this will help us do is to lay out what the period and all the key points are on the graph. If you look up here, okay, for instance on this graph here, notice that I've got a beginning, a top point, a middle, a bottom point, and then the middle again. So when we do this, there are 5 points that help define where this graph goes. We're going to use those in doing it with any one of these that changes the amplitude and the period. So let's start with this first one. Probably the simplest thing to do is to start with the amplitude. Notice that it's just the number in front. So I'm going to write down amplitude is equal to 3. So we're going to go up to 3 and down to negative 3. Now, this is a sine graph, and the number on the inside affects the period. It affects it inversely. Remember, if we do it in degrees, we're going to take 360 and divide by that number. So our period for this one is going to equal 360 divided by 10. So our period for this problem will be just 36 degrees. So now, because I'm asked to do 2 periods, don't go all the way out to the end of your graph to put that 36 degrees. I'm going to put the 36 right here in the middle, just because we're going to set up that as what our unit standard is. So 36 degrees, I'm going to end the period there. Now, next thing I want to do to get the rest of the key points is I'm going to split the period in half. So I'm going to go right here in the middle of it, and that's going to be 18 degrees, halfway to 36. And then what you do is you take each of those halves and split them in half again. Well, halfway to 18 degrees is 9 degrees. And if we're going, now we've established we're going by 9 degrees each time. And so if we go by 9 degrees, that would make this one 27 degrees. So now when I draw my graph, sine starts on the axis in the midline. You go up to the top, to the midline, to the bottom, and then to the midline again. Here is 1 period of sine. Okay, so we use these 5 key points to draw the graph. Now it does ask us to do a second period. So if 1 period is 36, I'm going to go take this distance and go that far out. So try to keep your units about the same. So this would be 72 degrees to come out here. I'm going to split that in half and then each of these in half. Well, if I'm going by 9s now, I know I'm going by 9 degrees. This will be 45 degrees. This will be 54 degrees. This will be 63 degrees, and then that will get us out to 72. So drawing my second period here, it's going to be start here, go to the top, go to the middle, go to the bottom, and go to the middle. So drawing my graph now, there's my second period for it. Now, that's 2 periods. If you were just asked to draw the graph, you might put arrows on the ends to show that it does keep going. It can go for an infinite number of periods because it keeps repeating that sine wave. All right, let's try the next one. Let's do cosine, 8 cosine of 1/2 x in radians. Now, first of all, let's do the amplitude. That's the easy part of it. So amplitude is just going to be equal to the 8. Now, I'm on this unit. I don't have to say if this is 3 here, I'm going to have 8 way up here. I'm on a new graph. Make the units make sense on this one. Set the standard for your units here. So I'm going to just set 8 up here, and then I'll have that distance down here for -8. Now I'm going to go ahead and figure out my period. Now I'm in radians, so what it tells us to do for radians is take 2 pi and divide by the number in front of the x. That's going to end up stretching it out because if I divide 2 pi by 1/2, that's the same thing as 2 pi times the reciprocal when you bring it up. So that gives me 4 pi as my period for this graph. So I'm going to go ahead and again, even though 4 pi is much larger than 36 degrees when you compare radians to degrees, I'm going to put it right here in the middle because I got to get 2 periods in. So 4 pi here. I'm going to split that in half. I get 2 pi. Split each of those in half. This will be pi. Now it looks like I'm going by pi, so this will be a 3 pi. I'm going to lay out the second period here. So I'm going to go out to 8 pi out here. The same distance out here. Split that in half. That'll be and this each of these, so that will be 5 pi, and I'll have 6 pi, 7 pi, and then 8 pi. Now when drawing my graph, I'm going to start cosine. It starts at the top of the amplitude. So you make sure you start it at the top, then it goes through the midline, then down to the bottom, through the midline to the top again. through the midline to the bottom, through the midline to the top. There's two periods where it just look like this. So you get used to drawing these sines and cosines, and there's it where it ends at two periods. So what we've done is we've set up the family of functions for sine and cosine. They have the same look. In fact, they are just, one is shifted 90 degrees from the other. That's because they're co-functions, so their angles are complementary. But then what we've done is looked at sine and cosine. That sine starts at the midline, cosine starts at the top of the amplitude. We talked about how the amplitude and period can change. The number in front of the trig function changes the amplitude, stretches it or shrinks it vertically. Whereas the number on the inside, you divide by it, so it affects horizontally the stretch or shrink inversely because you're dividing by it. And then we can use this 5-point method for coming up with a period and being able to come up with the key points for drawing our graph so we can draw sine and cosine graphs.